This is the second part of the concept module on programming in geospatial technology. It is strongly recommended that you look at the first part of this concept module before you go to the second part, because we'll be referring to things from that part in the second part. We're going to look at branching statements where we make logical decisions, and we're also going to look at looping type statements where you do the same process over and over for different parts of your data set. So you only write the process once, but then you use it multiple times. And then we'll have some concluding remarks to understand a little bit more about programming. So again, this is the second half of a module on programming in geospatial technology, and if you've not watched the first part, that is strongly recommended. So a decision-making type command. Typically these are referred to as if statements. Again, the names may vary a little bit between different software packages, but all software packages have some type of a comparison statement where you're comparing two different component parts. Thus, a decision is made. So the decision is going to be either a true decision or it's going to be a false decision. And you're going to go different ways with your data if it's true or if it's false. And then you can have multiple embedded branches inside this, and we'll talk a little bit about that in a moment. A lot of times in the IDEs, you'll see that decision-making statements are right indented a little bit so that we can see what's inside that branch versus what's inside the main part of the code. So here's a little flowchart diagram on a very simple branch in which a decision is going to be made. We've started this by giving a value of A, B, and C. These values of A, B, and C are hard-coded values, and in a lot of programs this might be a dialog box where you ask the user what are going to be the values of A, B, and C, but in this case, to keep it simpler, we have just used values here. And we've used very simple: A equals 1, B equals 2, and C equals 3. Obviously they can be much more complex values. They could be based on other variables in a lot of different ways that we can look at this. So then we come to the diamond shaped bracket, which is our decision. And we've used the word if, which is a programming command inside Python. Again, this command is usually there in most all other scripting and programming languages. And we've just said B is going to be greater than C. So let's look at the value of B. The value of B is 2. The value of C is 3. 2 is not greater than 3. So therefore, we're always going to get a false statement because we hard-coded the variables here. And that's going to drop down vertically to an else statement, and it's going to change the value of C to be C equal to A minus B. And then we have a print command that we do, and then we leave the decision, the branching statement, and we print done. Let's assume that B was greater than C, so B, let's say, had a value of 4 instead. Again, it cannot happen in this way we've coded this, but let's say B had a value of 4, then 4 would be greater than 3. We'd follow the true branch, and in this true branch we're going to just print the value of variable A, which would be 1, and then we leave the branch and we move into the continuing in the program, and we print for this case, for this simple case, done. You can nest if statements inside of if statements. So in this first example we had only a true or a false, but we could have a true, and if it's false we could have another if statement and ask another question, which is there, and if that's true it gives you a different resulting answer, and if it's false it could either end or it could go to another if type statement and ask another question of the data. So you can do these multiple internal loops of decision making. So here's a little bit more complicated loop where we've got two decisions that's going to be made. Again, we've hard-coded our values of A, B, and C. Again, in most scripts you would not hard code these. These would be variables or something that you could input data to. So we have hard information here. So we have our first if statement, which is just like what we saw on a previous slide. And we're going to compare and say, is B greater than C? Well, B is 2 and C is 3, so that's false. So instead of dropping to an else statement like we did in the previous diagram, we're going to drop to an elif statement. So this is referred to as else if. So if the first if statement is false, then we have this else if statement, and we're going to ask, is B equal to C? Well, again, in this case, B is not going to be equal to C, and we're going to drop down to the false statement again, and we're going to print bad input as part of the else statement, and then we're going to leave the branch and print the word done. Let's say we were in a case where B was equal to 2 and C was also equal to 2. Well, we go back and look at the first diamond bracket. B is not greater than C, so we again are false. We go to the else if statement and we see that B is equal to C. It's going to move over and print B equals C. It's going to print what's inside that set of quotation marks. Then it's going to drop out of the branch and print done. If B had had a value of, let's say, 6, and we look at this else if statement, so if B was 6, if 6 is greater than 3, yes, that's true, we're going to print the value of A, which is going to be 1, and then we drop out of the branch and we print done. So here's how we ask multiple questions within the same area of our data set. Depending on what the answer is, depends on what we do with it. We've just shown print statements here, but these could be more complicated subroutines that are done depending upon what is the answer. We need to understand a little bit about Boolean algebra. There's two basic statements we need to make sure we understand, and that's the AND statement and the OR statement. It's a little hard to write that on a slide because we're trying to write in general English, but then we have these commands that we're trying to write and they have been capitalized. That's not saying that's how they're going to be in a script, capitalized. An AND statement is comparing two variables. So A and B is A. So let's say A is greater than 3 and B is greater than 2 for some reason. We look at the values of those variables and we say, is the value of A true? Is the value of B true? If they're both true, then we get a true result. So think of our if statement. We would then have that as our true branch. If either of these is not true, then it would fall into our false branch of our if statement. But if we use instead the OR command, then OR means either one of them can be true or both of them can be true and get a true output. Only when both of them are false would we follow the false pathway. So again, you use this Boolean algebra to make informed decisions. Most scripting languages also have some type of a looping statement. And if you look at the diagram on this slide, we have a set of inputs. We have a for loop. For is a typical name for this type of loop. You'll also see there are other names and they work slightly different. And so with this loop, it might be comparing the values of a word. So if you're looking at a certain word and you want to look at each individual letter of that word, when you've used up the word, you drop out of the loop. So that's the right branch there. If you haven't used up all the letters in the word, you do some type of an operation and you go back to the loop and say, am I done? Or do I still have letters that I haven't used? If I'm done, I follow that right pathway. If I'm not done, I go and do the operation again. The operation most likely will have different values of the variable. So you can think of a loop as sort of like a subprogram. As I stated a moment ago, there are while statements in Python and for statements. Some languages only have a single type of statement in it. So you just have to understand the language that you're functioning with and how it uses this. So you might have one loop contained within another loop. So maybe I have a counter that's counting, and I'm going to do something 10 times. And then I have an inner loop that's going to do something 6 times. So the first time through, I go to the inner loop, do it 6 times, drop out of the inner loop, back to the outer loop, and I then go back, and I've not done it 10 times, go back to the inner loop, do it 6 more times, and so on and so forth until I've actually done this process 60 times. 10 times on the outer loop and 6 times on the inner loop each time that we change the value of the outer loop. So there's this nesting of loops just like we had nesting of branches. So many times within an organization you have a process that's going to be done, but you're going to do it numerous times. So for example, we do these clips and we do these merges. So you're developing for a state a bunch of regional geographies. These counties function as a unit for whatever, maybe an organization within the government or whatever, but a certain set of counties function together. So those counties that function together, we want to then do a regional map for that area. Maybe it's a tourism map as part of what we're doing. And then we want to extract things from another map, such as a statewide map, and we only want to look at things for the area that we're interested in. Or you're building a road map for that area, and you only want to look at specific areas. So if you write your script hard-coded with the names of those counties that's going to be merged together, then you have to go in the code each time and change the values. But if instead you write it in such a way that it opens up a dialog box and you input the names of the counties you want to merge together, then you can make this a much more detailed script. So building your own tool windows is possible in most scripts that can be ran then inside the software that you're trying to use. Most applications programs in geospatial technology, such as ArcGIS Desktop and QGIS and others, give you the ability to write Python within the application. Sometimes it's only in immediate mode, other times it is in a full editor mode. So it just depends on the application. Also, some functions you can use and write scripts to control those functions the way you want to see them controlled. So for example, ArcGIS Desktop, when you're doing the labeling function, it gives you the ability to write either a Visual Basic script or a Python script to control things the way that you want to control it. So say the attribute table has a bunch of abbreviations in it, and you want to change those to the full names on the map when you label the map, you can actually do this as a script inside the labeling function. You can do that also in the field calculator in ArcGIS Desktop, and again, this varies between applications if you can do it or not. So to be able to write full scripts within the application is possible in certain programs. Also, to be able to control a specific task by writing a script is also available. Again, it varies by application. This concludes part 2 of programming in geospatial technology. If you have questions, feel free to contact us and we'll be happy to provide answers for you. We have a model course just on using Python in geospatial technologies that you can download the information off of our website and learn on your own. Also, many of our partner institutions have Python classes for geospatial technology that you can take as a credit-bearing class.